And I don't take time to send somebody out and go over it with one group and not with everybody. So, my motto in life. Excuse me? Yeah. All right, moving on. All right. 4.1, angles and angles of a triangle. Talked yesterday. First off, review. What did we talk about yesterday? We talked about angles.
Acute triangle.
We talked about triangles, and then I also talked to you about the classifications of triangles based on their angles, right? Okay, and so we went over that. Yes, Chloe. I'll ask a question in a second. All right. So we have 4 classifications that I gave you. We went over yesterday. Does everybody agree with this? Remember this? Okay. The first one was what, Chloe?
Acute triangle.
Acute triangle, and that one says that it has what? Contains what?
Contains 3 acute.
All right, somebody else, give me the next one.
I have a right triangle.
Right triangle, good. We have that. And how many angles are right triangles?
Just the one.
Good. All right, and then the third one is? Obtuse. And how many obtuse angles are there? 1. And then the last one, which is not on the notes, is? Equal angular. And that means what? It has how many what?
It's equal.
Equal angles. And what is that equal angles equal to?
Each side is 60.
Each angle is 60. Good. 60. Good. All right. Now, any questions so far? We're good? So that's a quick review. Just a quick review. We're going to move into the next stuff. Everybody good? All right, here we go. Somebody tell me what this triangle looks like to you.
A right angle.
Looks like a right triangle. Good. Why does it look like a right triangle? What's this symbol right here?
Because C is 90 degrees.
C says 90 degrees. Good. So let's talk about this briefly. Okay, so if we have that triangle, which looks like a 90-degree angle, and it is a 90-degree angle, can somebody tell me what AB is? The name of AB is? AB is across from C, so what would it be? Hypotenuse. The opposite side of the right triangle is an hypotenuse. Now, you don't have to write this all out. If you want to draw a picture, okay, you just want to do, like, for instance, if I was writing the notes out on the board, I would write it just like this. I would draw a little right triangle, and I would go across from here to the hypotenuse. Okay? And then, you don't have to write out all the words. It's just saying so you can see what the words are. All right? The other two sides, AC and CB, are called legs. Legs. Just like you have 2 legs, the right triangle has 2 legs. Okay? All right? That makes sense? Alright, so if you want to label, if I was taking notes, this is how I would take notes. Leg, leg. And that would be done. Any questions on the labeling of a right triangle? No? Alright, good. So, can somebody tell me what is the Pythagorean theorem? Based on information you know, because you should have learned this, what is the Pythagorean theorem? Yeah.
A squared plus B squared equals C squared.
A squared plus B squared equals C squared. Now, looking at this here, A squared, which is this side right here, AC squared, CB squared equals AB squared. Does everybody follow? Here's the drawing. Here's your illustration right there. A squared plus B squared equals C squared. So the legs are added together are equal to the hypotenuse squared. Does that make sense? Everybody follow that?
Yeah.
And that's important. Any questions on that? So if I gave you an illustration, okay? If I gave you an illustration of the Pythagorean theorem and one that would possibly work. 3. Someone tell me what X is. It's a right triangle. I'll give you a second to think about it. 3, 4. Can anybody tell me what X is? Yeah. 5. 3, 4, 5. Does it work? Yeah.
Yes.
3 squared is?
9,
4 squared is?
16.
16 plus 9 is?
25.
25,
What's the square root of 25?
5.
It's amazing, isn't that right? Isn't that cool? How about this one? Five, 12, and somebody tell me what the hypotenuse would be. And how would you solve that? Brandon? What would the hypotenuse be?
144 squared.
Oh, no.
43.
Mhm.
13.
13. Watch how we get it. Watch. A squared. A squared. 5 squared plus 12 squared. Oops. 12 squared. Equals x squared. 5 squared is what?
25.
144.
25 plus 144 is?
169.
Okay. Now, how did I know that that works? Because I know that 169 is the square root of 13. Okay? All right? I have memorized up to 30, essentially. Why? How many problems in your math book? And I used to make you guys laugh when I first started teaching, because I memorized them, I made everybody else memorize them. So one of the assignments was you had a quiz on knowing the square of number 1 through 30.
And you couldn't figure out where to.
Couldn't show work, you had to have them all memorized.
Oh man.
Not gonna do.
Get a scramble.
You know what, I think that's a great idea. Thanks for all, no, we're not gonna do it. All right, but I figured, hey, listen, if you know, and that, it's just important. It's quick math, you can do it in your head. All right, you can do it in your head if you know those squares. So that's why. So, any questions on how to do the Pythagorean theorem? Here's an example. Everybody follow what it is. Any questions? Speak now. Forever hold your peace, because we're moving on to the next thing. All right. Here's classifications according to sides. Classifications according to sides. There are 3. The first is a scalene. The word scalene. Scale. Yeah. What is it?
1.
Has no congruent sides, or all sides are different, or only one side's the same, right? So it's 1. First one. Why it's number 1 is because it's the first one, which is only one side's the same. That's what scaling means. Everybody follow? Everybody good? So what's number 2? Has 2 sides that are equal. So somebody tell me the definition or the word that you would know is true of a triangle, the name that has 2 sides being equal. Chris? Isosceles. Well done. Look at that. So if you do classifications, 1, 2, 3, right? 1, scalene. 2, isosceles. And then, lastly,
Equilateral.
if it's equiangular, then it's going to be equilateral. Equilateral is all 3 sides are equal. So number 3, by the way, 1, 2, 3. So somebody tell me, this slide that's up, what is it representing? The,
Sides.
Classification
the 3 ways to what? Classify triangles according to their what?
Sides.
Good. Any questions so far? Are we good?
No.
No questions?
So if something's equilateral, like if they ask you can something be equilateral and isosceles at the same time?
Well, let's think about that for a second. Hope just asked a great question. Let's help her. Hope asked that if they're equilateral, are they isosceles? Sarah?
Yeah.
Hold on. I want a reason why. Not just yeah. No. All right. Tell me why, Sarah. What do you think?
Because if it has 3 congruent sides, that means it has 2 congruent sides.
Good. If it has 3, then it has 2. So really, this is just a more specific version of it. That's all. But that's good. That's good critical thinking. Does that make sense? That's the goal here, is that it's not just rote memory, it's also understanding it. Because the true-false question that Mr. Komsek may choose to write is this: all isosceles triangles are equilateral. And the answer is what, Dylan? All isosceles triangles are equilateral. True or false? All isosceles triangles are equilateral.
False.
Why?
Isosceles has 2.
Only has 2, so there's some that might not be. So let me ask this question. All equilateral triangles could be isosceles. True. Does that make sense? So gotta read carefully. I hate true false. I don't write a lot of them just because I can really mess you up with them, and I don't really choose to do that. All right. Other people do that to me, so it's only fair. All right. So everybody see my triangle there? Can somebody tell me what these little red marks mean? They're not just equal signs. They're marking that. Yeah, equal sides. I'm sorry, equal sign. I thought you said. So GF and GH are equal. Why are there 2 tick marks and not 1 tick mark or 3 tick marks?
Because they're 2 sides.
No. Well, I mean that's a possibility. I mean, but is it necessary that they have to have 2?
Yes.
Have 2 congruent
No.
That's why we're asking the question. Thanks, Dave. I don't know. I'm asking the question. All right? Yeah.
Is it because, well,
Technically, couldn't it have one, but
Yeah, could
if
have
it
one.
was another shape that had other, like, more sides, more than just 3 sides, then
Can I mark it like that?
yes.
I second that.
I could. I could mark it like this. I could, yeah. You can do whatever I want. I'm a teacher. Right? But that's true. So let me ask this question. The reason I say to you, this doesn't, I don't know, I honestly don't know why they put 2 marks. They don't really need to. But I'm asking you because I want you to start thinking through why things are what they are. Okay? Here's a question. What's going to happen in this chapter? We are going to start comparing 2 triangles like this.
Oh, this is wrong.
And what's going to happen is,
Oh.
now it's important. Why? Because this side is going to be congruent to, and this side is going to be congruent to. Does everybody follow me? Are we clear now? So it doesn't really matter on this drawing, but it will matter on this drawing.
Sir.
Does that make sense?
Yes, sir.
So that's why I asked the question. It's good for you to think through. So, really quickly, 2 congruent sides, that makes up the isosceles triangle, right? Can everybody tell, look carefully with me. If that's an isosceles triangle, then the sides of an isosceles triangle are called the legs. Okay? They're also called the legs. Can somebody tell me what this would be of an isosceles triangle? FH.
Hypotenuse.
No? The base. Good. The base. The third side is called the base. So if it's an isosceles triangle, the sides are labeled leg, leg, base. If it's a right triangle, you're labeled what? Leg, leg, hypotenuse. Does everybody understand the difference?
This was isosceles, right?
Everybody good? Yeah. This is isosceles. So that's the difference between isosceles and... You guys should be thankful I have a PowerPoint for this. I mean, I'm thankful because I don't have to write it all on the board. That's really what it comes down to. And oh, by the way, I will send this to you in an email later, just in case you missed anything or spelled something wrong, because some of you probably did. Yeah,
What do you call,
I
like,
have
you
no
know,
idea.
yay, that was quick. But what do you call the triangle point thing?
Up here?
So there's a triangle, right? And on
Like
top
this
of it's a
triangle?
point. Yeah, the G, that's the.
G, yeah.
The G.
So what do I call that?
Yeah, what do you call it?
I don't know. What would I call that?
Point G.
There you go. Look at that. The angle formed by 2 legs is called the vertex angle.
I know, right? Just a little bit longer.
Isn't that terrible? So I really lied to you because I didn't know.
Well, you kind of didn't lie because you said that for the questions in the past, so therefore you did not know what you were technically lying to, so therefore that.
All right, debater.
Accept it. Sorry.
There's
You're
no
not.
debate.
I just have to accept
The
it.
two angles at the bottom are called base angles, F and H. Okay? So, this is important. Why is this important, guys? Why is it important that you know what these things are called and what it looks like and how to label it? Because what's going to happen very soon is this. I'm going to say to you, hey, give me the angle, the vertex angle. And if I say that to you, what does that mean to you now? What it means is that it's an isosceles triangle. Does that make sense? Is everybody following me? That's going to have to come to your mind. So if I were to say to you, give me the hypotenuse of something, you're going to have to say, okay, I'm going to have to use what to solve for hypotenuse? I need a right triangle. I know it's a right triangle. I also now know, does that make sense? That I have to use the Pythagorean theorem. That's why you need to learn this information. It's not easy, but it is important. Okay? All right, moving on. You don't need this, move on.
Oh, no.
Here comes some theorems. Right down path. This is easy. Hey, listen. Everybody look. Everybody look up. Don't stress yet. Stress later. Here we go.
Oh.
Here it is. 411 for your information. Okay, you guys have you ever dialed 411?
No, but
Yes.
So back in the day when I first started teaching, like way back in the day, it's a long time ago, 411 was something that people would dial all the time, and that was for information. You guys, like, now that Google is in place, you guys don't even know what 411 means.
I do actually.
All right, so here we go. Here's the triangle sum theorem. 411, triangle sum theorem. In other words, listen, the sum of the measure of the angles is how many degrees?
180.
180. You already knew this theorem. This is just now a theorem in place. Yo, listen, do you need to memorize this entire theorem?
No.
What should you make sure to know?
Measure angles, triangle is 180.
What should you know?
180.
Okay? If this is a fill in the blank, the question is going to say the sum of the measures of an angle of a triangle is blank.
That's really game show.
Everybody follow me?
Yes.
Don't take a lot of time. There's two key words to this thing. Sum and 180. Okay? Those are the words you need to make sure to know. And here you go. Look at your picture. Why? Here's the reason. Everybody look. And this is a proof that you will prove at some point in your life. Watch carefully. Look. 1, 2, 3 are angles inside, everybody. There's the three angles inside the triangles. Everybody got it? Are we good there?
yeah.
Notice, please, if I draw a parallel line right here with AC, can somebody tell me what angle 1 and angle 4 are? What kind of angles are they? Alternate in,
Exterior.
alternate interior, because they're interior between these two lines.
Oh.
Can somebody tell me angle 5 and angle 3, what kind of angles are they?
Interior.
Alternate interior. So class, listen and look. Alternate interior, substitution. Alternate interior, substitution. Can anybody tell me, is this a straight line?
Yeah.
What do you know about a straight line? It equals how many degrees?
180.
And there's your proof why that triangle equals 180 degrees. Does that make sense? You couldn't have done this until you learned alternate interior angles. Now, a lot of you knew that triangles were 180 degrees. You already knew that. But you didn't know why. Geometry is the why to mathematics. All right? Isn't it awesome? Isn't it awesome? Aren't you so proud that you now know the why?
It's like color.
I know. It's awesome. All right, here we go. You don't necessarily need to know this,
Okay.
So you got it?
but it's important to understand. So that's why we'll read it. Okay, watch. Listen to what it says. The acute angles of a right triangle. So first off, let me ask you a question. How many acute angles are in a right triangle? 2. Why? Because the third angle of a right triangle is what?
Right angle.
See me after class. I can't even keep straight face. I wanted to know so bad.
I thought you were serious.
I couldn't even keep a straight face. Alright, here we go. Yeah, steak, that was my opportunity. Missed it. Alright, next one's coming. Alright. Acute angles of a right triangle. So there's two of them, right? The third angle of a right triangle is a right angle. Does everybody follow me? So class, can I ask you a question? Think about this. How many degrees is a whole triangle?
180.
180. If you subtract one of those angles, which is 90, how much do you have left?
90.
90. Look,
I'm sorry, can you explain it?
I just did.
I know, but like, it went, it didn't.
Faith, don't talk, because I haven't finished explaining it all the way. 180 minus 90, because this angle is the right angle, which gives me 90. Now read the rest, go back to the words. The acute angles of a right triangle are complementary. Class, please look at the board. What is this number right here?
90.
So look, remember, how many angles are acute angles in a right triangle?
2.
The two acute angles of a right triangle have to be complementary because you subtract 90. They're not going to be 45. They can be, but they don't always are. Okay? Does that make sense? That's the explanation. It makes sense, right? Good. That's all you need to know there, all right? We already did this one. Each angle of an equiangular triangle is how many degrees?
60.
You don't need to memorize this number. You already know it. Everybody good? All right, moving on. Next theorem.
Oh boy.
This is a fun one. This is my favorite. 4.1.2. I have favorite theorems. Yep. Just like I have favorite
Students.
Yes.
students. Yeah. Do I have favorite students? I don't know.
Yeah, you
I haven't
do.
decided yet.
At least you have least.
I haven't decided who my favorite student is yet this year.
Have
I'm
you
still working
decided
on it.
who your least favorite student is?
Oh, that's definite. Yeah, that was definite. Joke.
That was
All right.
Oh!
What? I was talking about Aaron Judge, the baseball player, because I was thinking about the World Series.
Was he your student?
He was my student.
Oh, he
Yeah.
was. It's too bad they're not in it anymore.
Yeah, I know. But I don't know why you guys would think, anything other than that. Come on. You guys are putting words in my mouth. Come on. All right, here we go. Watch. I have two triangles. Everybody good? Everybody ready for this?
Yeah.
4.1.2. Here it is. If you have two angles of a triangle, so you got to look up to my drawing. When you're ready to look up to my drawing, I'll show you. I don't want to read something that you are not paying attention to. Because otherwise I'll have to re-explain it, and I don't like to re-explain things. I'm kind of a
That's
glutton for not punishment.
One and done.
Glutton for not punishment.
One and done.
All right, here we go. Ready? Everybody done writing down that theorem?
I thought we were gonna. Oh.
Look at the drawing. Here it is. Follow the drawing. You will need to put in words, but it will be pretty easy. If two angles of one triangle are congruent to two angles of another triangle, then the third triangles are congruent. Watch carefully. Here it is. If I have two triangles, everybody see these two triangles?
Yeah.
And I say to you, this angle is congruent to this angle, and this angle here is congruent to this angle here. What do you know about that third angle? Why?
because all the rest are congruent.
Because they have to add up to 180, and if these two are both equal already, then these two are equal.
That's all you have left.
Look at 4, and here's how you remember it. This is how I remember the number. 4 minus 1 is equal to what?
3.
How many? What are we talking about? The third angle.
Oh.
That is
You
not
go,
right.
Mr. Comstock, that confuses me. Well, I'm sorry, it helps me. Okay? So if it confuses you, forget it. If it doesn't confuse you, use it. Okay? But here's how I remember, because on the test, it's going to be a fill in the blank. It's going to be a fill in the blank. Watch. Everybody look. What do you think I'm going to ask a question on? It's going to deal with these numbers right down here. If how many angles of one triangle. 1, 2. Are congruent to how many of the other? No triangle. Then the blank. How do I get that? 4 minus 1. So that's how I remember it. I just look at my number and go, oh, so 2 and 1, 1 and 2, right here. And then what? 2. Because what questions am I going to ask? I'm not going to ask you to tell me this word here, another, or if, or of. I'm going to ask you to say 1, 2, 3. Is that fair? Any questions? Just try to help you memorize. Because I know you guys love to memorize. So I'm trying to help you eliminate. All right?
And skip it through.
All right, here we go. Let's do this problem together, and then you can. Then I'll give you some homework. Here we go. Find the measure of each angle. So 36, 60, 45. We need to find the angle 1. So somebody help me. How would we find angle 1? Tyler, what do you think we're gonna do?
So you add 36 and 60.
So he says to add 36 and 60. Does everybody agree with him?
Yeah.
All right. So let's see what happens next.
So that equals 96.
Plus 1, right, would equal 180. So you add those together. What do you get? 96, right?
Yes, sir.
What do we do now?
Minus 56.
Subtract it. What is angle 1?
84.
Everybody see it?
No.
Pretty simple.
Yeah.
Now what? How would we find angle 2, please? Somebody help me with angle 2. Sarah? Angle 2 is already on the PowerPoint. The answer is already in here, written out. You don't have to do any math, you just need to identify. If angle 1 is 84, what is angle 2?
96.
Well done. Look carefully, everybody look. 96, what is 96? It's the addition of these two. Everybody agree? Which are the, by the way, the exterior angles to number 2. They add up with this one to give you 180. So, if this is 96 and this is 45, somebody help me get number 3. How would we solve that? Dylan, how would we solve angle 3? If we know this is 96 and we know this is 45, what do we do first? This is 96 and this is 45, what do we do first? Add them, all right? So what do we get? What do you do when you add those together? What do you get? $141, right? Right? So what do I do to get 3? Subtract it, which is,
39.
and there's your answers. Everybody follow this? I see what you're doing? All right. We'll talk about exterior angles tomorrow and finish up this lecture. It's very brief. We'll talk about remote interior angles. This literally was 3 lessons that they taught all at once for some reason. They changed the book. The old book, this was 3 lessons, and for some reason now it's 1. Have a great time, Tally, watching our great video.